Hi there, my name is Miss Townsend and I love math. Welcome to Math with Townsend. This video is for grade 9 applied students who are looking for additional help as they prepare for the June EQAO. It's video number 10. In these videos, we've been looking at EQAO questions from last year's 9Applied EQAO. And all of those questions are available on the EQAO website at this address. And what I've been asking is that if you have any questions about the math, or if you want to see more questions on a particular topic, please just post in the comment section on the appropriate video, and I'll get back to you just as soon as I can. So let's go ahead and look at the last couple questions from that EQAO on this web page. So here's the first one. It says, a sail for a sailboat is represented below. The unshaded part is made with material that costs $32 per meter. Oops, wrong part. The unshaded part. Boy, it's important to read, right? Okay, so the unshaded part is made with material that costs $32 per meter squared. The shaded part is made with material that costs $125 per meter squared. Determine the total cost of the sail. Show your work. Okay, so this is obviously not a multiple choice question. It's a long response or open response question. And that means we want to show as much work as we can. And even if we don't quite know how to get the right answer, we need to do some math that demonstrates that we have read the question and we understood the principle. I mean, for example, at the very least, we can all spot that there is a right-angled triangle here. And that right-angled triangle represents the unshaded part. So you can easily find the area of the unshaded part and at least do that calculation, even if you're not sure what to do with the shaded part. However, let's talk about the shaded part. And I want to get rid of this. It was just there temporarily to cover up my diagram. So delete. When I look at this sail, here's what I see. Obviously, I see a right triangle that represents the unshaded part, and then the shaded part below, which is some funny shape. I think it's actually a trapezoid. So you are absolutely welcome to use the trapezoid formula to find the area of the shaded region, and maybe that's what some of you have done. But I'm not a big fan of trapezoids. I tend to think about the world as rectangles, circles, or triangles. So here's what I see. I see a big shaded in triangle where part of it has been cut away. And that's how I'm going to do this math. It certainly doesn't mean you have to do it that way, but this is the way my brain works. I like triangles, I guess. So there's my two triangles that I'm going to deal with. And so let's find the area of these triangles and then we'll deal with those areas. So they're both right angles. This one is 6, and this whole distance down here must be 8 plus 4, so 12. The other one, the little white one, I'm told that this is 4, and this distance here is 8. Now, this is an area question, so certainly I don't need the Pythagorean theorem. What I need to do is calculate the area of each of these triangles. So let's call this triangle 1, and I'm going to call this triangle 2. How do you find the area of a triangle? Well, look on your formula sheet. Area is base times height divided by 2. And base and height, remember, are the two sides that meet at that 90-degree angle. So I know for both of my triangles, I know the base and I know the height. So let me give myself some more room. Triangle number 1 has an area of 12 times 6 divided by 2, which is 36 meters squared. Triangle number 2 has an area. So again, base and height, I'm just going to scroll up. 8 times 4 divided by 2. So that gives me 16 meters squared. Now, I don't actually want this entire piece of shaded sail. What I want to do is I want to cut this much off of the shaded sail. So in other words, if I start with this big gray shape, I cut this part off, and the only part I really need, therefore, is what's left over here. So if I subtract, so if I do 36 minus 16, I'm going to get 20 meters squared, and that's the area of the shaded part. So the area of the shaded sail is 20. And now I can tell you the cost of the shaded part. The shaded part is $125 per square meter. That seems expensive. So cost of shaded part would be $125, and it's 20 square meters. So that would be $2,500 just for the shaded part. So now let's look at the unshaded part. Well, the unshaded part was this triangle that I've used to subtract. So I've already found its area. The unshaded part is the little triangle. So the unshaded part, oh, let's use blue. So the area of the unshaded part, which up above we'd called number 2, by the way, is 16 meters squared. And it costs $32 per square meter. So the cost of the unshaded would be $32 times 16 square meters. So 32 times 16 gives us $512. So the total cost is just the sum of those two values. So the total cost is 2,500 plus 512, which is $3,012. Oops, I didn't mean to change color ink, but whatever. There, $3,012. Okay, so I hope that that's pretty clear. And just in case anybody wants to see it, let's do this question. Well, not the entire question. Let's look at the shaded area again. We found using our method that the area of the shaded region was 20. And now let's find it again, but this time we're going to use the trapezoid method. So just bear with me. I know we've got an answer to this question, but we're just going to show you an alternate method. And maybe it's a method that you'll prefer. So let's get rid of some of this stuff we don't need anymore since we've gotten the answer. Delete. And let's look at this gray shape here as a trapezoid, which is exactly what it is. So the area of a trapezoid, if you look on your formula sheet, the area of a trapezoid is A plus B times H divided by 2. So A and B are the parallel sides. So in this case, it's going to be 6 plus 4. The height, so what's perpendicular to the base and to A and B? Well, the height must be 4. And then divide by 2. So 10 times 4 is 40. 40 divided by 2 is 20. So there are several different methods you could have used for finding the area of that shaded region. Okay. Otherwise, the question is the same. So the final question is a geometry question. It says, consider the diagram. Complete the table below with the values of x and y. Justify your answers. Okay, so here's x. Let's see. I've got a whole bunch of parallel lines. Parallel, parallel, and parallel. And then I've got parallel lines running the other way. So parallel, parallel, and parallel. Okay, so let's start thinking. So this is 59, so this is 59 because the parallel F pattern. Now this is 59 because there's another parallel F pattern. And then if we look like this, you can see that there's a C pattern. And in a C pattern, angles add to 180. So 180 minus 59 is equal to 121 degrees. So that must be the value of x. Now, how would I justify that? Well, certainly having written things on my diagram is part of my justification, but I would say parallel line theorem, F pattern. And everybody knows PLT. You don't have to write the words out. Do it if you have the time. Parallel line theorem, F pattern. And then I did parallel line theorem, F pattern. And then I did parallel line theorem, C pattern. So to someone who doesn't know math, this isn't much of a justification, but this says I use the parallel line theorem F pattern. That's how I got here because, and let me use my marker to show you, make sure. So I used this F right here. Then I used this upside down F right here. And then finally, I need another color marker. Let's see if I can get one. Let's see. You're seeing behind the curtain here, guys. Nope. Nope. Too much hassle. Maybe. Properties. Line style. Aha. I think I might be able to do this. Let's make it blue. Save. And let's see. What did we do? Nope, didn't work. Never mind. I'll use pink. So I have the yellow F, then I have the green F, and then finally we had this pink C pattern. And so PLTF, PLTF, PLTC, good enough for me. Now let me clean up some of this mess so that we can start to look at Y, meaning the letter Y, not pourquoi. That would be a philosophy course, not a math course. You can tell this is the final video, right? Because I'm being cray. And this last little pink here, I'm not going to worry about it. So now we need to find what Y is. So again, we know that this angle was 59 and this angle was 121. Now Y is contained within a triangle. And since I know this angle, I probably need to figure out this angle and then use the 180 rule to find Y. So how can I find this angle? Well, think about the parallelogram that's right beside where I'm looking. In that parallelogram, again, let's think about this. We have a C pattern. Oh, look at this C pattern. And that means that if I have 59 degrees over here, then I have 121 degrees right here because they add to 180. Or let's say you don't like that idea. Fine, you don't have to like that idea. Here's another option. You have an F pattern right here. So this angle is equal to this angle. And we already knew from doing the X that this was 59 degrees. Therefore, this is 59 degrees. So that means 180 minus 59 minus 48 equals my missing Y value. So 180 minus 59 minus 48 is 73. So let's go down here. Y is 73 degrees. How would I justify it? I would say parallel line theorem F pattern. And then I would say angles in a triangle add to 180. There. So that's it. We are done the questions that were left for us by EQAO from last year. If you post requests, I'll post more videos. Otherwise, study well, and I'll see you in school.